Okay. Good morning, good afternoon, and good evening, and welcome to everyone. Welcome everyone to Optimize Storage to Drive ERP Performance. Thank you for joining us. My name is Keith Thomas, and I will be your webcast host today. Before we dive right in, let me go over some quick logistical notes. Next slide, Mike. First, in order to minimize background noise, we've muted everyone's phone for those of you who have dialed in. However, we are very interested in interacting with you here today. There are two ways in which you can do that. First, you can respond to the polls we'll be posting during the webcast. And second, you can ask questions. The graphic you can see explains how to ask a question. Simply click on the icon, type in your question, and hit send. We won't be stopping for questions during the webcast, but we will answer them all at the end. Next slide, Mike. A quick word about Core Services. Since 1990, Core Services has been delivering Oracle hosting and managed services, consulting services, and cloud services to our global client base. We're an Oracle Platinum partner, and our solutions span the entire technology stack. And we're very proud of our maximum performance architecture and our custom monitoring solutions. Now, let me introduce the presentation team. First, we're joined here today by Michael Rolfe. Michael is the Core Services Chief Technology Officer. He's got over 2 decades in the managed services, in managing industry-leading architecture and product development teams at multiple Fortune 100 companies. He's also an active member in several both U.S. and global Oracle user groups, so we're very happy to have Michael here today. Next, let me introduce Namita Jindo. Namita is Intelligrated's Oracle Application Delivery Manager, and she brings us over a decade of experience in managing Oracle ERP financials and MRP solutions. And Sabrina is joined by one of her colleagues from Intelligrated, Sabrina Wiley. And Sabrina Wiley is a senior Oracle DBA with over 20 years of experience in implementing, upgrading, and supporting over 100 Oracle e-business suite instances for both private and public sector companies. And last, and certainly not least, we're also very happy and very proud to introduce Adam Rosenberg. Adam is an advisory systems engineer for EMC, and he's EMC's New York area expert on enterprise storage platforms. He also has electronic design automation experience, and so we're also very happy to welcome Adam here today. So let's take a quick look at our webcast agenda before I go ahead and turn it over to the presentation team. So what we're going to do today is we're going to start by beginning to talk about the impact of storage on the end user experience. You don't normally think of that as something that would have a huge impact on the kind of business side of things, but it does. And so we'll go into some of the ways in which that happens, some of the problems you can encounter, and some of the challenges that need to be resolved there. From there, we'll take a look at the evolution of enterprise ERP storage technologies. We'll also take a close look at the Intelligrated case study here. Intelligrated dealt with any number of these challenges, and they've made some significant progress on solving them. So we'd really like to kind of offer them as a real-life example on how you can make these solutions work for you. And then finally, we're going to talk a little bit about our architecture and our solution as it relates to enterprise storage and performance. So without any further introduction, let me pass it off to Mike. Mike.
Thanks, Keith. So for those of you that are maybe more on the technology side, you've probably realized over the years as you've worked providing enterprise systems and supporting the underlying technology for your Oracle environment, that database performance really is directly tied to the performance of your storage platform. If you look sort of at the two combined, the IOPS, or the way you measure transactional throughput on your storage platform within the drives, directly correlate to the number of database transactions per second that your database can execute. So as you start to see an increase in your transaction throughput, I'm starting to send more database transactions which require more I/O transactions per second, this can start leading to wait times within your storage array. Or I sent a transaction, I have to wait some amount of time for the disk to become available to either enqueue or write the transaction, or to retrieve the transaction from disk to return back to the database in order to be used by the database engine to present up to the end user. So what all this really means is as transactions go up, wait times increase, it correlates directly to slowness within the Oracle applications, whether it is waiting for a query to return a result, or in some cases even cabbing from field to field within the Oracle applications. Performance can become impacted if I don't have a robust storage solution to support the volume of data being processed by my organization. And this is exactly some of the sort of challenges that we saw that the folks at Intelligrated were experiencing. Namita?
I'm here. So just talking about Intelligrated in general before I really start talking about the point. Intelligrated is an industrial manufacturing company, and we are having EBS, e-Business Suite platform since 2002. Earlier we have just one manufacturing organization, so things were smooth, and whatever storage Intelligrated was, it was working fine. The issue really started when Intelligrated acquired FKI Logistic, and as per the processing perspective, like what Mike was talking about, like you have more I/O coming, and we will be having like 4 manufacturing organizations in Oracle platform, and so our day-to-day business process were increasing, more transactions were coming, and that's where Intelligrated start facing the problems. And here are the few pain points that were observed at the time. Like MRP, and everybody in e-Business Suite world knows like what is the MRP is. It's a material requirement planning, and that's a big time-consuming job and a big high I/O intensive job actually, and it requires for releasing the POs and WIP jobs. So for us, like, as we were increasing more in transaction and more in like, bill of materials and inventory, this job for every org was increasing, and the time was taking longer, and the impact was like our OLTP transaction in the daytime too, because when nighttime job will be running longer, they will not be finishing in the morning time frame, and then it was impacting our OLTP transaction. So it was impacting our day-to-day business processes. And while said that one, then my last point was the full gather schema. So, and everybody knows like what full gather schema in the database is, but in Oracle e-Business Suite perspective, Oracle have a standard job for that. And if it does not complete, at least if it is not completed at least a month, user may start seeing the problem in their day-to-day activities because you don't have the latest stats on the highly transactionable, table, and that was a issue as Intelligrated we were facing at the time. So these are like the challenges that we were facing on our online transaction as well as the batch job that were running in the night time on our old storage. Over to you, Mike.
Thanks, Namita. So growth in a business is a good thing. Intelligrated made acquisitions. They were seeing that their growth was increasing. Business was running quite well. But as this business grew, they started experiencing challenges due to the amount of the volume of data that was available to them, which directly, as that volume increased, as Namita has pointed out, directly correlated to a performance issue that they were starting to see in key aspects of the business. And as those systems and components slowed down, it had a direct impact on the end users. So Keith, why don't we put a poll out there?
second, Mike. Let me go ahead and get that poll started. 1 second. Okay. Can you see the poll, Mike?
So what we'd like to know is how some of you as end users, are you experiencing some of these same challenges associated with Oracle applications?
Okay. So we're getting some votes coming in. Everyone take a moment to vote on this, and we'll share the results and get the instant analysis from our expert here. And we'll leave this up for about another 15 seconds for all those who wish to vote. Please cast your vote, and then we will share the results with everybody. All right, let's give the stragglers another 5 seconds. And we will close the poll here. All right.
All right.
Can you see the results? Here we go. Sorry about that. So, what does this tell you, Mike?
As the presenter, I can only see my screen. My apologies.
Oh, okay. All right. All right. So I'll read out the results then, Mike. So what business challenges are you facing related to ERP storage? Slow runtimes for MRP and other time-sensitive processes. It doesn't look like we have any of our attendees here struggling with that pain point. A steady increase in data volume, that's hardly a surprise, and we see looks like 44% of the people are saying that they have that issue. And the top pain point is end-user performance complaints when large jobs are running, and that's coming in at 56%. And we're not seeing anybody here saying that they're having challenges completing maintenance tasks in a timely manner.
All right. So it sounds like people are seeing some of the same challenges that the folks at Intelligrated were facing. As we had these growth in data, that you're starting to see that the batch jobs start to take longer and increase and sort of have an overall impact on the business process flow. So with that, why don't we talk a bit about how storage has evolved, and we'll talk about a couple different storage models and how these models can address some of these pain points. So, looking at what you have, if you consider how Oracle E-Business Suite works, as most of you have seen, there's a steady growth in storage requirements. Oracle is very good at keeping a lot of information around. You have a lot of historical data is kept online for use by analytics packages, and also to help key processes like what Navita was talking about related to the MRP planning. But as we start to increase the data set for these common business processes, that has an impact on the transactional capacity within the database. And as more data is required to be transferred back and forth between storage, I start to see a performance impact. So there's a number of different challenges that we have to figure out how to address. One, how easily can I scale my storage platform to accommodate and provide additional capacity for this growth in storage requirements? And sort of in conjunction with that growth, how can I manage the throughput, the I/O per second, so that I can move that increasing data volume back and forth to make decisions and have the database engine and analytic tools make decisions based on that larger amount of data, while at the same time minimizing the wait time. Just because I have more data doesn't mean that it's acceptable to me to spend time waiting for a result. As Nimir was pointing out, that has a direct impact on the amount of time it takes for my processes to run. And if that wait time increases, key business processes may not complete in a timely fashion. Growing for capacity, increasing throughput, and minimizing latency all has a cost to it. And so as a business planner, I have to address some of the trade-offs. I need to balance the cost of additional technology against the value that it provides to the business. So there's a number of different ways that we can address that. And would like to turn that over to our friends at EMC to talk about how storage technologies have evolved over the years in terms of connection technology, and also how the systems are architected to address these types of issues.
Very good. So I guess it's on to me. This is Adam from EMC, and thank you all for joining. I guess to start with, I'd like to talk a little bit about how we're connecting up storage to the controllers or to the hosts that are actually trying to access the data. And historically, there's really been 3 different methods that have been used. There's obviously the old school approach of going in, just directly attaching storage to the controllers themselves. And there's some advantages to this in that it is a very simple thing to implement, but there's a lot of downside to it as well. Basically, I'm connecting directly up to the SCSI buses. I am only able to access disk through this one controller or through this one host that is trying to grab the data. So if any external hosts need access to it, they've got a single node they have to come down through, which starts to cause some bottlenecking. It isn't necessarily the most reliable solution either. Typically, we see these things down with maybe about 4 nines of availability. So, unplanned downtime can become problematic here. On the plus side, I do have direct access to the storage, and I can get fairly quick access, but it isn't necessarily a scalable solution for me. And we've seen this as something that's been available for a while, but it kind of drifted away, and it's starting to come back again. I don't know that it's got a strong hold, but I know that it's definitely got some folks that are interested in it, particularly when we're looking at things like high-performance compute clusters. Another area that we look at are things that involve network-attached storage, and by that I mean where we access it via some type of Ethernet-type connectivity using an IP protocol. The way that we typically architect these are such that you're grabbing data that's either an NFS or a CIFS share, depending upon the flavor of OS that you're running. These typically have integrated filers, so we're not using an external server to grab this data or a server that has dedicated storage behind it. We're actually taking a pair of controllers for redundancy to give us some level of reliability and accessing that data, and it typically gives us a fairly good access method. It's a little bit slower because it is over IP, and it's not necessarily deterministic that if I request something, then I'm going to get it on the first go, but I can get fairly good response out of it, and I usually am in the 4 to 5 nines range of reliability or availability. So it's fairly good. What's nice about it is that I can grow it out and attach it to numerous servers and give access to the storage across entire clusters or across entire organizations. The next method that typically is used is the SAN method, or storage area network, and these are usually the most resilient systems. Again, these start off as dual controller systems, although there are abilities to grow these things out to numerous controllers if necessary. Typical connectivity is either an iSCSI type connectivity over an Ethernet type fabric, or going over fiber channel, which tends to be where folks who are involved in trying to do high performance compute try to go. And the bulk of the folks that I work with tend to like the fiber channel connected solutions. Now, granted, EMC offers all these different solutions to you depending upon what you're trying to accomplish, but the tendency for most of my users is to be on fiber, particularly when we're dealing with database access. Can we move to the next slide, please? So I like to think about storage, now that we've talked about connectivity, is really having 4 fundamental architectures that almost any storage that's out there can fall into. The first, what we call type 1, is really a clustered dual controller type architecture. And these are very much the general purpose arrays that are available and seen in most of IT departments today. They are able to handle a variety of workloads, and that's what makes them interesting. There is some limitations to them as well, and we'll go into each of these architectures in a little more depth in a moment. The second type that we're going to talk about is these type 2s over here, which is really what we consider a loosely coupled scale-out architecture. And by that I mean I'm able to add in more control or more controllers to do the compute for me, which gives me more access to the disk and higher speed access as well. This usually involve a large number of independent controllers. They're interconnected through some internal networking that distributes the data across all the nodes, as well as distributing metadata between the nodes. And these really help us to ensure that the data integrity is maintained throughout the entire architecture. On the third type of architecture that we look at, which is still, we're still on the same slide, I apologize, I'm going a little bit slow here. We're looking at more of a tightly coupled scale-out architecture. And this is one that allows me to expand both performance and capacity simultaneously, where I may be locked in on the number of controllers I have in some of the earlier architectures that I just talked about. These are really known for low latency, high performance type and high availability type compute. We have a large memory space that's shared amongst numerous nodes, and it appears to be a single memory space from the outside world. And lastly is a Type 4 architecture. Really, it's a distributed architecture where absolutely nothing is shared between the nodes. It's just ultimately a collection of compute nodes. They're connected via layer 2 fabric. The Type 2, it's similar to the Type 2 architecture, but the differences really occur down at the software layer where we're not sharing metadata between nodes. So I can't guarantee consistency of the data that I'm dealing with. Everything that I'm doing is eventually consistent, but at a moment-by-moment look, the data may or may not be available at any one of the nodes. So these are not necessarily used for the typical database structures that you're working with, more dealt with things like NoSQLs and so forth. Can we move to the next slide, please? So just going a little deeper into the Type 1 architecture, and the reason that we look at it is typically it's the best balance when we look at cost versus performance versus availability. Ultimate cost of entry is fairly low. It's very well integrated into numerous environments. They're capable of communicating over many different protocols, things like iSCSI or fiber channel over Ethernet. I can do NFS. So many different ways to approach attaching to these devices. They're typically dual controller though, and that limits the amount of availability I'm capable of having. It doesn't allow for much scale as well. I usually get about 5 nines out of these availability, which is fairly good uptime as far as systems are out there. And ultimately, I'm really at the, if I need to go and get more performance out of these, I need to do upgrades that involve either swapping out controller heads or moving to newer, faster hardware. So I'm kind of locked in once I go down this route. Could we go to the next slide, please? So the Type 2 architecture that we talked about just a moment ago is really built for scaling. What we do is we prioritize simplicity of management. We look at the cost of the capacity that we're putting in place, and we try to scale out performance and availability as well with these architectures. So these can scale to thousands of nodes, and that's a huge win over here. And if you look at the economics of scale, it gives us a great dollars per gigabyte trade-off. I'm able to add controllers as I need to if I need additional performance. And that distributed metadata allows me for some very good communications between the nodes, which essentially provide me, as an end user, millions of IOs that I'm able to push to these devices. Next slide, please. For the Type 3 architecture, which we're showing over here, these are really for your most demanding workloads. These will scale very well, but they'll also provide extremely low latency. And these have some of the most stringent requirements for availability out there. And these are typically more in the 6 nines of uptime, required for industries where you can't really have equipment go down, where you can't take outages if you need to do upgrades. They really focus on recoverability, availability, and scalability. So you'll hear RAS if you get involved in storage discussions. And these pieces of equipment really are the tops in that field. They're fully redundant active-active data paths throughout the device. They're really meant for mission-critical type workloads, and they'll go up to petabytes of capacity. However, your cost of entry winds up being a little bit on the higher side over here. And these architectures are the ones that Core Services is offering up at this moment. Can we move on to the last slide, or the next slide, I'm sorry. Lastly, I'd like to cover the Type 4 category, which is more what we would consider an environment where my commits for writes don't necessarily occur at the same time, so I can't guarantee that pieces of the data that I'm storing are going to all hit disk at the same time. They really favor economics over simplicity and persistence of rich data services. They're not necessarily bulletproof as far as availability or bleeding edge performance. The cost of entry is very low. These are typically purely software running on commodity hardware. And they start off as a small single node environment, but they can scale out to huge, huge capacities. So if you're looking at scale and you're not much concerned about when the data hits the disk, because that's not important to you, these work out very well for you. In database environments, not necessarily a great choice, though. And I am done on that slide.
Okay. Thank you, Adam. So let's go ahead and launch our next poll. Let me get that started here. Oops. And this is going to take the temperature in terms of what storage platforms everyone's using. So let me go ahead and launch that. We'll keep that up, and let's see what people are using. All right, getting some votes in. Getting some more votes in. The options we have here are direct attached storage, of course, network attached storage, traditional SAN storage, and flash storage. So whichever one of those you're using, please vote for that. And we'll keep this poll open here for another couple of seconds for those of you who still wish to vote, as I still see votes coming in. And once everyone's got their vote in, we'll do what we did before and share the results. And we'll have our instant analysis from Michael. And you can't see the results as they're coming in. That's correct, Mike? Mike? Mike, have you muted yourself? Mike?
No, I can't see. I'll need you to share the results.
That's
I
fine.
need you to share the results.
No, I'll share them here in a moment. So it looks like everyone who's going to vote has voted, and we'll go ahead and share the results here, and I'll let you know verbally what they are, Mike. Let me go ahead and close the poll. And here we go to share the results. So what storage platform are you currently using? We don't have anybody using direct attached storage. Okay, that got 0%. Network attached storage, we're getting 13%. Traditional SAN storage is getting 63%. And another 25 are reporting that they're using flash storage. What does that tell you, Mike?
Well, it sounds like the people on this that are attending this webcast are doing better than a lot of folks out there in the industry. What you're seeing, many service providers outside of Core using, a lot of them are still using a network-attached storage due to the ease of management, and not necessarily everyone is working with SAN storage due to the cost and complexity. For those of you that the 25% that are already making the transition to flash storage, you're in a really good position. So, and we'll talk a bit about why that's important here in a moment. So let's go back.
Sorry, Mike. Go on.
So let's go back and review some of the challenges that we were talking about before Adam spoke about the different types. So we were seeing a steady increase in database size. Core is experiencing this also within our customer base. We have 1,000-some database instances under management, and we found that consistently, regardless of the customer, that as Intelligrated sees, there's a steady increase in growth. And not only is the growth increasing, but the complexity of the analysis, and which directly correlates to the amount of I/O required, the IOPS, is increasing as well. The Oracle applications are becoming more complex. They give you more ways to do analysis, And as that data volume grows, there's more and more information that needs to be pushed back and forth between the database and the storage platform. And so one of the challenges that we were seeing at Core to support our clients was with some of these traditional storage platforms, such as NAS, or in our case, traditional SAN platforms, was that we were regularly having to rebalance the storage to address hotspots caused by key components within the application. So for example, what Intelligrated was seeing in terms of MRP runs corresponds to a certain subset of tables within the database. So that means that information is traditionally being read and wrote to the same area within disk. And so I would get hotspots that, while my system would scale up in terms of capacity to meet the increase in database size, I was still seeing high latency because the storage platform was trying to always access those same spots on disk. And so my latency would start to increase with workload independent of database size. So as Core was looking to address the problems that Intelligrated and other clients were experiencing, we had a number of solutions available to us that we had talked to the folks at EMC about. One, just to deal with the standard increases in database size, was just to increase the size of the disk pool, the amount of disk available to the client. And while I could get more disks and get more capacity, I still was stranded or was restricted by the access speed of the individual disk. So the physical disk constraints started to have an impact on my ability to scale. The other thing you can look at doing, which we were also performing, was increasing the amount of storage processors. This gives us more capacity to process requests, but it's also a very expensive component to scale. A storage processor is typically one of the larger cost items in your storage architecture. And as I would increase this capacity, I would start to strand some of my available space within my array, because I couldn't take full utilization of the space available, physical space available within the array, because I was starting to max out the throughput that I could send things to and from the array itself. Another option was to increase the cache. So instead of having to wait for things to read and write to disk, I read and write to memory. This is another high cost item and can also start to lead to bottlenecks, because at some point I still need to interact with the underlying physical disk. So the final solution that we found as we were working through the growth and capacity expansion with Intelligrated was to actually look at switching platforms. And so what Core actually ended up doing is moving away from a traditional SAN architecture based on physical disks and starting to deploy more on the straight flash storage platform. And we found that this had a number of benefits. So Namita, why don't you talk a little bit about some of your experiences through this journey of evolving storage technologies?
Sure. Miss, I can definitely talk, like, on the basis of how we have moved from 2011 to 2015 here, and I talked earlier, like the challenges that we have faced, not in general just MRP. We have so many bad jobs. We have so many user requests that get submitted during day and night that were getting impacted earlier, and then they were like a day-to-day online transaction that was causing the screen slowness. So we were earlier on a VNX storage, and then we were moved to VMAX storage back in 2012, and that gave us a lot of, at least relief on a lot of things around the day-to-day processing and nightly jobs. But as I mentioned, the data growth was huge. We were increasing every single day based on how many acquisitions were coming in Intelligrated, and how much data was coming from legacy system. And in 2012, again, we brought another, legacy system into Oracle. That brought like a lot of other data, back in 2013. So our pain point was not decreasing at all. We keep asking core, for handling our storage better, and I knew we have from VNX to VMAX. And finally, in 2014, we went to flash storage on top of VMAX, which these slides represent, some of the benefit that we achieved during the flash storage transition. Because, as we were growing in the data, MRP time keep increasing, nightly batch time keep increasing. We were having still pain point on the OLTP, where some of the screens were having slow. People were complaining that when they copy the purchase order, they were slow. There were a lot of pain points in a lot of transactional data too. And then we went to flash storage back in July 2014. I can see clearly reports can tell me we have average we have 25% improvement in all the batch process. Some of the batch process even we have seen the 40% to 50% improvement, but average I can tell it was 25% overall. OLTP transaction were pretty smooth. Even the user jobs, if users submit any kind of reports, they were much better. Means 2014, after that flash storage move was pretty smooth. We haven't seen any major issues, with the user reporting too, except one or two. Those are very rare, where user kicks some reports, out of blue moon that you have no control. But other than that, I can see it was pretty stable. Sabrina can talk more in next slide, how it also improved in our DBI, which are more on the analytical side of processing too. Can you move to the next slide, please?
All right, so this slide basically, it's another one of our nightly jobs. Actually, this is a weekly job we run over the weekend that performs analytics for users to use throughout the week. It runs Saturday night to Sunday. And before our move to the EFDs, we had issues with performance, and it would spend the entire day Sunday running this. As you can see, it was running, 7-8 hours at a time. And after our switch, we've got it down to about 4 to 5 hours, which then frees up time on the Sunday afternoon for us to run some other things, such as gather schema. So this is being able to run gather schema during the week, or more frequently, is obviously helping us also.
Absolutely. Thank you. Thanks, Maria. Thanks, Sabrina. So let's sort of recap here a little bit. So as both Sabrina and Namita have mentioned, there was a direct correlation that we were able to find between the type of storage platform that was being provided to them with end user response. And as Intelligrated experienced growth and as they've progressed through their relationship with Core, the storage platform that we have provided has evolved to meet the needs of a large growing company. And so one of the things that Core has developed is this maximum availability storage architecture. And what we have started to do is move away from traditional storage technologies and move to an exclusively flash-based storage solution. And so if you look at traditional disk, that gives you maybe 30,000, 40,000 IOPS. When you go to something like EMC's Extreme I/O solution, you get a factor of growth in getting to 150,000 IOPS, which really allows you to manage these compute-intensive, data-intensive operations like an MRP run or an extract to support an analytics process. The other nice thing about the Extreme I/O platform is that issue of hotspots, because certain pieces of data always reside in the same place, is eliminated. Extreme I/O actually balances across the array trays the storage layout, so that I no longer have to be worrying of, even if I have enough controller capacity, have I optimized my underlying storage utilization. So we've really eliminated this hotspot problem. We've addressed the issue of overall throughput by providing a high number of I/O transactions, and we've even eliminated the need for storage replicas. Extreme I/O has a very strong set of tools that allow me to manage multiple copies of the data. So typical tasks that you have to perform in an eBusiness Suite instance, such as cloning, recovery, rollbacks for testing, etc., are greatly accelerated because of how Extreme I/O manages replicas on the disk. And because it's designed in a block model, it scales linearly as a cluster as I grow my environment. So the challenge that you saw in more traditional disk-based storage systems, where I had controllers and clusters of disk, has gone away, so that I get better correlation of I/O performance to storage performance. And what we found, where traditionally you had to try and get the best value for the performance that you required, we have found by switching to Extreme I/O, we can give you the best performance and the best price, instead of having to perform that balancing act between performance and cost. So, Adam, maybe if you could explain a little bit about how the Extreme I/O product family works and what's available.
Sure. So real briefly, Extreme I/O was something we launched maybe 14 months ago. Officially, it hit the ground about that point in time. It's actually the fastest growing product in the history of EMC, and it's outstripping sales in virtually every other category of storage that's out there, because it not only gives you a ridiculous amount of performance, it also provides some great economic gains as well. And a lot of it has to do with the architecture of the unit. It is definitely something that's deeply embedded in that Type 3 architecture I described before. It's very much in line with the VMAX equipment as far as the reliability, availability, and scalability aspects. I can start off with as small as a single brick. Brick is just the term we use to describe a node or a pair of controllers and the disk behind it. And we can grow that thing up from there onto 6, 8 bricks, depending upon the configuration you want to go before we start building out additional clusters. Every one of those bricks comes with a fixed amount of storage associated with it. And if we start talking about usable storage versus the raw storage, I give you a bad feel for what's really inside of the unit, because the way that data is stored in that unit, it is able to, as the data comes in, do inline deduplication on the data. So it finds 4K blocks of data, it hunks up the data as it comes in into 4K blocks, and if it's ever stored that same data before, it tosses it out and just increments a pointer. So as data is streaming into this unit, it's doing deduplication on the fly. Additionally, it's also doing a compression algorithm on the fly. So when we start looking at the way data is stored on this, by design, it's doing deduplication, it's doing compression, it's thinly storing the data. So if you've got 0 blocks, they're not being stored on the device as well. So what may start off looking like 15 terabytes of usable capacity on a brick, by the time I'm looking at deduplication on a data plate, on the database, maybe I get 30% deduplication. Then I run compression on top of it, which has to happen also before I can store the data. You have no way to turn it off. I'm getting another 2x improvement, so I'm now 2.6x the amount of storage that I started with. And then you start looking at thinly provisioning it, and you're probably looking at another multiplier on top of that that gets you in the area of 10 to 20x the space that's actually physically available on the disk. It's really a phenomenal way to store the data, And when you look at the economics of the space savings due to that dedupe, the compression, and the thin provisioning, you start to see that the overall cost is very much in line with the VMAX type storage. So you've got a very solid storage platform. It's able to produce a huge number of IOs. I mean, we're talking on the read side about 250,000 IOPS per brick. I can maybe on a VMAX front-end controller get 20, 30,000 IOPS if I want. So we're well exceeding what you're able to get in the VMAX product line and deliver the same level of availability and reliability that you're seeing in that product line as well. I think that pretty much covers, at least at a high level, the Extreme family. We could always go deeper at another time if it makes sense.
Thanks, Adam. So Core has partnered with EMC to make VMAX our storage platform of choice that we offer to our clients. And what that means is we can very quickly scale out additional capacity to support growth needs of companies like Intelligrated, while at the same time maintaining that very low latency response time for the database, typically less than 1 millisecond, which is almost unheard of in traditional storage systems supporting a database, while at the same time not having to deal with a lot of the typical hotspot and tuning and other performance issues associated with storage, so that you can focus on your business performance and the overall database performance and not have to spend as much time worrying about the underlying technology. Core manages, maintains, and supports all of that for you. So with that, Core would like to, we would like to offer, for those of you that are on the call, to schedule a one-on-one assessment with one of our storage experts in conjunction with EMC about how Core and EMC can assist you with some of your performance, database and storage performance issues. Keith?
Okay, so I've gone ahead and launched the poll. We'll keep it up here while we're getting to the questions that you've asked. I know a number of questions have been posted, and you give me a moment, I will go ahead and post those questions. One question I can answer is, yes, you will be able to get a recording and a recording of this webcast. Tomorrow at about the same time, you'll get an automated email message. And that message will give you a link where you can access an on-demand version of this webcast. So, and that will go to everybody, both you, all the attendees, and everyone else who registered and maybe wasn't able to make it. I know some of you may have had colleagues or friends who have registered, and things come up and they weren't able to make it. So we're going to go ahead and keep this poll up for just another couple of seconds. I see we've got a couple people requesting the one-on-one, so we'll get that we'll get in touch with you here today. The rest of you, no worries. So let me get to the question. Let me go ahead and close the poll. And Mike, can you switch the slide? Mike, can you switch to the next slide? So, quickly again, if you have not asked a question, you can hit the icon as that's demonstrated here. You can see the graphics that we have. Go ahead and click that in and, start asking your questions. So, I'm trouble seeing this very well, but what type of cost-benefit analysis, hold on. Give me just a second here. I'm having trouble viewing the GoToMeeting Q&A interface. Hold on. I'll get to your questions here in just a second. How do these options that you've discussed here today impact disaster recovery?
So that's a good question. So Core's looked at a number of issues over the years on how to address disaster recovery, and we actually have an upcoming webinar, I believe, in May talking about DR strategies. But one of the nice things about EMC's technology is they also have another product line called Recover Point that works both with their SAN-based, traditional SAN-based storage, such as VMAX and VNX, as well as also shortly going to be working with the new Extreme I/O technologies, so that you can deal with replication not only locally to additional storage arrays to provide a backup copy, but also to remote locations. And in our upcoming webcast, I believe in May, we'll be talking about some of those technologies and how Core can help you with your disaster recovery requirements.
Excellent, excellent. And that webcast, we're going to try to schedule that for April, Mike, so no worries there. And we'll have more information on that coming soon. Our next question comes from Sear. Sear wants to know how easy can users transition from one storage platform to the next? If someone's invested in, and you saw the poll earlier where people are now, how easily can they make that jump to the types of cutting-edge solutions we're talking about here today?
Sure. So Core, one of the things Core is invested in is building a very robust methodology for helping with storage translation. And I believe Namita and Sabrina can attest that as we've moved them, or as they've migrated through these various life cycles of storage technologies, it's really been transparent to the end user with very little impact as those upgrades occurred. Namita or Sabrina, would you comment?
Yeah, this is Namita, and I can definitely talk that one because we went from VNX to VMAX as well as with the flash storage on top of it last year. For end user perspective, there is really for them, they only see the performance increase and that's all. But for the IT perspective, definitely as a IT group, you have to run your test to make sure there is no issue. But we haven't faced any challenge while doing those transitions during our IT testing. But we made sure that we did one iteration before doing that storage change in production. So that was always our strategy, doing those storage transition from one to another.
Thank you. So as we've done that within our environment for our clients, it's been a fairly transparent process for people that are looking to make a transition from a current provider or in-house deployment to Core to take advantage of technologies such as this. Core also has a very robust methodology that allows us to do that, make that transition with very minimal downtime based on the processes and technologies we put in place to assist with that transition cycle.
Okay, we have another question here from Peter, and I'm not sure if he's making a clarification or asking a question. So Peter, if I'm getting this wrong, feel free to correct me via the Q&A interface. But I'll frame this in a formal question. Can storage transition, or he's saying storage transitions can be performed with Recover Point or VIPR. Do you have anything you want to say about that, Mike?
Yeah, can you repeat that?
Well, it's not really formed here as a question. So Peter, if I'm getting this wrong, please go ahead and ping us again. But Peter put into the Q&A interface, he says, storage transitions can be performed with Recover Point or VIPR.
So the transition can be done, well, we use that more for a DR strategy. What we have done, because of the way we have architected storage at Core, whether you're using VMAX traditional disk, VMAX with flash storage, or Extreme I/O, all of those are really managed as tiers of storage. So we can move sort of seamlessly between those components with little or no downtime, depending on how big of a leap you're up the chain you're going. So it's not necessarily a function of Recover Point that's doing that for you, but the way that storage tiering works within Core's architecture.
Excellent, excellent. Another question we have, and I think this is probably one that's pretty common out there. You know, you see and hear all kinds of issues about performance issues and all kinds of horror stories about that. And what Sear wants to know is, how do I know if storage is actually the root cause of the problem?
So that's a good question. There's a number of key indicators that you can see. One, if you're a system administrator, for example, you can go in at the OS level and you can look at what, there's a couple parameters that you can look at around percent busy or I/O waits. And those, if you start to see that the database is waiting on I/O, or at the OS level, if I'm starting to see the percent busy increase, that's a pretty good indicator that the storage platform is the underlying issue. Core also, we've developed a number of tools and techniques internally that allow us actually to correlate between database transactions per second and storage IOPS. And we've built a number of tools, we discussed this in a prior webcast, that allow us to correlate storage and database because they are such a tightly coupled and so close and impacting pair of technologies. And so if you have the opportunity, maybe you should view the previous webcast we did on monitoring technologies.
Excellent, excellent. We're running up on time here, but we do have one final question here from Anish. He's wanting to know what type of cost-benefit analysis can you provide regarding flash storage? It's a big question to squeeze into the last minute here, but can you, what can you tell us, Mike?
Sure. So what we've found at Core, based on how we have architected our new flash solution, is through the technologies EMC provides around deduplication, compression, and other related efficiencies, that the cost per gigabyte of flash storage is roughly equivalent, and in some cases, as your number of instances that you manage go up, the cost per gig actually decreases below the cost of traditional disk spindle-based storage. So at Core, we'd be very glad to share some of the efficiencies that we've experienced and how, share how we've been able to leverage flash storage to give sort of that best performance for the best price.
Excellent, excellent. So we're right at time here. We want to thank everyone for coming out and joining us here today. We also want to thank our presentation team, Namita and Sabrina from Intelligrated, and of course Adam from EMC. We want to thank you guys for taking your time out here and thank you for sharing your experiences and helping us make this a success. As Mike mentioned, we're going to have another webcast talking about disaster recovery, looking more EMC solutions in April, and next month we're looking forward to having a webcast on Oracle managed application managed services, and that information will be available, and you'll be able to register for that very soon. Once again, thanks everyone for your time, and we look forward to seeing you at our next webcast. Thanks, Mike. Thanks, everyone.